Classic area maximization problem. It says this: farmer has 800 feet of fencing, and he needs to make 12 corrals like this. I know they don't look right, but trust me, pretend like those are all equal sizes. What dimensions produce the largest area? Here's how I would do these problems. First of all, I write my area equation, which equals x times y. That's easy. Then I write my perimeter equation. 800 is my perimeter, and that is 1, 2, 3, 4, 5 x's plus 1, 2, 3, 4 y's worth of fencing. Now what I'm going to do is take this equation, and I'm going to solve it for y and plug that into here for x, so I have a quadratic equation. And quadratic equations are nice because they look like this, or they could be upside down, but this will be, or they could be right side up, but this will be upside down, which means there's a maximum point. I want that point right there. The x value of that point right there is equal to negative b over 2a. I'm going to find out what that is, and then I'm going to find my maximum area, and I'm going to also find the dimensions going backward. So that's the game plan. Now let's do it. When I solve this I'm going to wave my hands over this. Y equals 800 minus 5x all over 4, which means 200 minus 5/4 x. That's what y equals. Now let's plug that back into here. I'll change colors, going green on us here. So area in terms of x equals x, that's this, times y, which is this, 200 minus 5/4 x. This is a quadratic equation. When I put it in standard form, I'm going to move it around a little bit. That's 5/4 x squared. I distributed the x in, plus 200x. What's my x value that would produce that? Now you could use your graphing calculator, but sometimes that's hard to do because you have to then find, first of all, you got to plug it in right into your graphing calculator. Then you've got to be able to zoom in or out so that you can see it and you can find the max and the min. Not always easy to do. In my opinion, it's easier just to use this. Negative b over 2a. So what's negative b? That's this. So your x coordinate of your vertex is negative b, which is negative 200, all over 2 times a, which is negative 5/4. Now watch what I'm going to do here. Cancel the 2's, so that becomes negative 5/2. Flip and multiply, so that's negative 200 times 2, negative 2/5. Negative times a negative is a positive. 400 divided by 5 is 80. X equals 80. X equals 80. I'm running out of room here. X equals 80. If X equals 80, then what does Y equal? Well, let's find our equation. What did we say? 800 equals 5x. 800 equals 5x plus 4y. Plug that back in. 80 times 5 is 450. Subtract 450 from both sides. That's 350 equals 4y. Am I doing this right?
Yeah.
No, it's not 450. That's 400. Don't be an idiot like I am. So this is 400, which is nicer because those are nice round numbers. That's why I kind of thought, am I doing this right? Divide both sides by 4, I get 100. So what are my dimensions? 80 by 100, and how big is that?
8,000.
So if they're asking you for, it's 8,000 square feet is the maximum area, and the dimensions are 80 by 100. Much easier to do that problem if you just use negative b over 2a.
So you recommend not using your calculator for the maximum?
So do I recommend using your calculator or not using it? I recommend knowing both methods, but usually on these problems, it's usually easier to do negative b over 2a. If you have a graphing calculator or an app on a calculator that quickly and easily finds it, that's not a bad thing to do either, but you kind of have to know how they both work and be able to use them. Sometimes you have tests and they don't allow you to use calculators, so you definitely need to know that negative b over 2a trick. The third way you could have done, which is even more complicated, is to take this and put it in vertex form. So let me show you how that is. Negative 5/4 x squared, was it 200 plus 200x? Remember this little trick where you factor out the negative 5/4 and then you find something to add and subtract? That would be a mess right here. That'd be a mess. But that is another way you could do it. And then you would have this as your answer. You'd have negative 5/4 x, or our answers again, 80 and 100, x minus 80 squared plus 100. That's what you would, if you did that, that's what you would have had. You'd have x minus 80 squared plus 100. Because that's your 80, 100 is your vertex.
The negative b over 2a is solved.
I'm so sorry, that's not true. That's not your vertex. You'd have 80,000. Is that what it was? Because that's actually my area equation. This is area right here. So my maximum area was 8,000, not 80,000. So sorry about that. That would be your equation if you did completing the square, which would have been kind of a pain in the butt because of that.
Yeah, we learned that a little, but
Sometimes completing the square is really nice when you have nice even numbers right here.
Why do I need to do completing this?
Well, completing the square gives you your equation in what some books call standard form, some books call vertex form,
For this
and
would
you'd
be
have 88,000.
8,000. All right.
But completing the square can be more complicated, more often than not.